Welcome to Shifting Knowledge Left, Keeping Up with Modern Application Security. I know it's the end of the day, so we're going to dive right in. Maybe.
Well, go on, dive.
I'm trying. I'm clicking harder. We're going to use the arrow keys.
All right.
So this is Mark from Duo. Don't worry about it. It's fine. I'm Fletcher from Hunter 2. We've been working together to engage engineers in AppSec and make the security training experience better for engineers. If you want to know more about who we are, you've probably looked us up already. So we're going to dive right into the talk. We're going to start with the general state of developer security knowledge as it currently stands, the need to reduce time to education in AppSec, and especially why that's important over the last few years, given trends in the industry. Mark will talk a little bit about what they're up to at Duo in terms of engaging and enabling engineers from their security team. And then we'll go into changing course on security education and ways to grow the community. We'll wrap up with sharing a tool that we're opening up a platform for some free training resources that we hope you'll also be able to give back to. So to start out, the state of developer security knowledge. We'll start with the OWASP top 10 because it's such an industry standard. When you talk about AppSec, it's the first thing people gravitate toward. First published in 2003, it's become a de facto standard. So from OWASP themselves, the OWASP top 10 is a powerful awareness document for web application security. Represents a broad consensus about the most critical security risks to web apps. It's necessarily broad. It's intentionally broad. Now, OWASP as an organization has grown significantly, and they have over 125 different projects. Such as the Application Security Verification Standard, ASVS, is a really wonderful checklist of security controls that you can use as you're developing an application. Unfortunately, the OWASP top 10 has been overloading a bunch of what OWASP is as an organization. And so we tend to gravitate toward it as our catch-all for all of these topics and all of these needs. Now, it's true we can start with the OWASP top 10 as a good starting point, and we should do more overall awareness, build some awareness among engineers of that list. Nearly 1 in 5 developers aren't familiar at all with it. However, this is much more than a talk about just the top 10, because it's not all of these things necessarily. It's not up to date. It takes multiple years to come out with the next version. It's not even language or framework specific. So as a C developer, as opposed to someone developing a Node.js web app, I probably have very different security concerns. I probably have a different threat model depending on the business and the product. None of that is necessarily covered in a very broad set of top 10. It's also not a checklist for code scanning, for pen testing. Now, you'll see a lot of vendors who say we cover the full top 10. It's good and it's expected because that's what we're asking of them. But of course, it's a very broad set of categories, so it's hard to say we cover all of injection, for instance. On the same note, it's not an exhaustive list of all vulnerability classes. And most importantly and most relevant to this talk, it's definitely not a training syllabus, even though whenever any of us is developing an AppSec workshop, we'll probably start with the top 10 and make sure we hit a little bit of each point. So where do new students get this knowledge when it comes to security training? If you're taking the most traditional path, let's say you went through a comp sci program before heading into the workforce. Here's a list of the top 10 CS programs. I'll let you guess how many of these require just one course relating to software security. That's it. None of those. Now, to be fair, a lot of them, most of them offer security electives, but that's usually more policy-oriented or focused on privacy or low-level at best technical topics like buffer overflows. Usually things like modern web development or even version control aren't even covered in traditional education. Likewise, if you even went through a coding bootcamp that is teaching you how to build modern web apps, chances are you don't get much knowledge of anything AppSec related through that process. And at worst, you're learning the wrong things. So you've entered the workforce. Let's say you are a new developer using a new language, new framework. Maybe you're working in, let's say, Rails, and you need to access a database. Your incentive is to get things done quickly and ship some code and show that you know what you're doing while you're learning all of this on the fly. Let's take a look into what your life might be like there. A moment in the life of a developer. Rails SQL, yeah, I'm feeling lucky. What's the first result here? 372 votes, great. Let's copy paste, Stack Overflow driven development, and I'm done. I have my database result. I'll go through that really quick one more time just because that's fun. This was not a cherry-picked, hard to find example. This was just the first thing I tried. And to be fair, Rails as a framework has a lot of really great sane defaults to keep you safe. It has a very well-built ORM. The Rails documentation itself also says all sorts of places, here are warnings against doing exactly this. But it's still very easy to fall into those traps, especially as a new developer who hasn't been given that framework yet to know what to look out for. So it's up to us, their employers, to help educate and to get developers up to speed. Meanwhile, though, with the trends in DevSecOps, we're asking them to do more with less all the time. So taking on more areas of responsibility, now taking on more of security as an engineer day to day, without the training or background to do so. This was from a recent report that GitLab did, where they said 70% of developers are expected, as part of their job descriptions and part of what they're measured on their performance, to write secure code. At the same time, less than half of them get any sort of feedback on security. So we expect them to do it somehow out of the ether, to get this knowledge and put it into their day-to-day work. But they don't even know if they're doing it right or wrong. We don't tell them afterward how things are going. And developers are smart. 25% of them think that their organization's security practices are good. So they know something's up. But we haven't shared all the right stories, all the right lessons with them yet. Instead, especially as busy security professionals, we end up dumbing down topics, and that ends up expanding possible risk. So we say things like, just use the ORM, which is a good start. That might have prevented that I'm feeling lucky database query. But it's not real code security. And again, it's an incomplete answer that can add a false sense of security. Just use the ORM isn't necessarily good enough, or just use this package. A lot of the time that's through infrequent annual trainings where things can go out of date. We could say use this header, and it turns out that's not best practices anymore either. But real code security is about defense in depth. It's about modeling what threats are actually possible, thinking like an attacker, and making the practical trade-offs to write reasonably secure code. And these best practices evolve. So, there are many pen testers probably in the audience. You probably relate to the frustration of saying, oh, I can load a Metasploit module, therefore I can pen test, without knowing what it does, what the vulnerability is, how it works under the hood, or why you're using that particular module. That's a pretty close equivalent to when we say, just use this browser header. Now you can prevent cross-site scripting. So we don't need to get into all the nitty-gritty inner workings every time, but giving some more context around the trade-offs and around the relevant details to a developer can go a long way. Instead, in terms of best practices evolving, we often see things like this. So the XSS auditor is a experiment for attempting to prevent cross-site scripting automatically, to help out developers, to especially help out end users. Chrome would block this in your browser automatically and say, this looks like cross-site scripting. We're not going to trust it. And so there's a tendency, especially in developer training, to skip over or downplay the client side, and even more so when we have tools like this, to say, Chrome will take care of it for you. Well, it turned out adding this in is a really, really hard problem to solve automatically. And it introduced as many or more potential vulnerabilities as it tried to address. And so has been deprecated. Another quick example, HPKP. So this is public key pinning. This is for preventing, you're verifying a domain, preventing man-in-the-middle type attacks. The RFC originally for HPKP was back in April 2015. A few months later, Google rolling this out automatically, so you can, there were lots of great blog posts about you should turn this on. This is a great security improvement to keep your site safe, keep it securely loading. It turned out, though, that there were no takebacks with HPKP. This was by design, but again, if you're just implementing this quickly, you don't necessarily understand the innards, all the details of what you're implementing, you could end up bricking your site more or less. And so a lot of people ended up saying, well, how do I hit undo? And the recommendation here was use a different domain. You won't be accessible for quite some time, so best of luck. So come mid-late 2016, some questions about, was this such a good idea? A lot of folks have been breaking their sites and breaking access by accident with no takebacks. Into mid-late 2017, Scott Helm, who was an early cautious proponent of HPKP, saying, I'm giving up, it wasn't worth it. And finally, a few months later, intent to deprecate. So these best practices, as I said, evolve. It's much more than just saying, plug this in, follow this tutorial. Besides getting some context on what the possible downsides could be, we need to think about defense in depth, and what if this gets deprecated? How do I protect on my own as well? Now, these are more specific, more advanced specific topics here, but to go back to the basics for a second, around SQL injection. It's true that even the basics, the standards that have been around for over a decade now, continue to appear in our applications left and right. So this is a pretty steady graph you can see from 2011 through 2017 of applications vulnerable to SQL injection. Likewise, according to HackerOne, cross-site scripting, the most common weakness successfully exploited in their bug bounties. So it's time to stop pretending that what we've done works. And we're actually seeing that this is causing even more problems over time with the fragmentation of tooling and of the ability, for instance, of anyone to publish an NPM type package. So we made a quick graph of CVEs relating to parsing. You can see this little blip in 2000. I haven't thought about Y2K in a while. But there's a huge spike there of the last few years. And a lot of that is the perennial cross-site scripting, XML injection, things like that, coming up in more and more new tools that new people are building. But there's this explosion in recent years of this happening. So what do we typically do about this as security teams? A lot of the time, we rely on SAST and DAST, and we scan, and we identify vulnerabilities, and then we call it a job well done. Instead of, how often is that a real feedback loop? How often when you get those results, do you tell some developers about it? Do you tell the developers who wrote that original code, share that feedback, make sure that they aren't making those same mistakes repeatedly? Instead, a lot of the time we end up handing off to an early in their career security analyst to pick through the signal versus noise. And that can create a lot of extra work or even some missed lessons there, where scanning is great. We should be using this, absolutely. But we want to make sure that that's part of a holistic approach that also includes the developers in those lessons learned. Another really common result here is wishful thinking as a vulnerability management strategy. So it's very easy with this fragmentation of tooling, especially, to say, we're not vulnerable because we don't use that particular library, that particular version, without getting into the details of what is the underlying concept there, and might it still apply to us in some way. And I'll hand it over to Mark to talk about one of those examples in particular.
So last year at Black Hat, Kelby Ludwig at Duo Labs within Duo Security released some really great research around attack against SAML that was kind of a new vulnerability class. So not a lot of people know what XML canonicalization is. Most people don't read RFCs from XML. So the overlap between the list of CVEs you see up there, in a lot of organizations, it's going to be predicated on a vulnerability management program where you've got one or many tools saying, this vulnerability applies to this library, you should patch, high CVSS score. If you simply took our advisory through CERT and looked at this list of affected libraries, what you didn't take away from it is that this is a kind of implicit potential vulnerability in all SAML implementations. So if you didn't look at actually how XML canonicalization happened for your specific SAML library, you could also be vulnerable. But if you simply looked at the list of affected libraries and say, oh, we don't use that, you could still be vulnerable. And I was actually at a product security incident response conference when our research came out, and I had people say, great, awesome research, thank you for putting that out to the public. And I said, oh, are you affected? And they're like, oh, we don't use any of those libraries. I said, but are you affected? And this is kind of where we end up at a bit of an impasse. There's this reliance on vulnerability management tools without necessarily understanding the root cause. And so much of what we see, especially like with the OWASP top 10, we're shaving off a lot of nuance, and engineers are nuance driven. They understand very technical things, yet we keep kind of dumbing things down, as Fletcher mentioned, until we've removed and abstracted all of the actual things they need to know. This is only increasing, as Fletcher mentioned, because whether it's the increased number of frameworks or languages that are popular, or just the pure amount of code and software engineering that's happening in the world, we've got to get ahead of the problem. Instead of looking at 2 to 3 year lagging indicators like OWASP top 10, it's really not keeping up with the needs of the engineering people that we in AppSec, for instance, support. It's great to say, hey, did you know that 3 years ago SQL injection was still bad? What about like that esoteric bug class in Node.js? You might not hear about it for 3 years. That doesn't really seem like a way that we're ever going to get ahead of the problems that we're facing. So looking at this graph, you might assume that I'm pulling up data from 1995. This is just IBM's presentation style for graphs. So this is actually from 2010. But one of the things that we think about in the industry, there's a lot of tropes in the industry that we just take as fact. One of which is it's way, way cheaper to fix a vulnerability farther left in the development lifecycle versus farther right. Here's some data from IBM that seems to agree with that kind of implicit thesis that we all have. But when you see these numbers, it's not in the ballpark, right? Like fixing it in design, doing it on a whiteboard before any code's written, yeah, it's dramatically faster versus the far right side, which is the maintenance mode side, and a little bit more expensive, right? 100 times. Lots of organizations that you may have worked for, worked with, especially large enterprises, could look something like this. You've got a platoon of software engineers, all around the world with different business units and different teams. You've got some, people in compliance that are enabling the business to sell products into, regulated markets or provide the necessary overhead to, allow organizations to leverage your products. You've got lots and lots of products. And then you might have some security people. And in fact, if you looked at this and you saw a bunch of people in software testing, you see some security engineers, you see some pen testers, some of you might want that as your organization. You're like, wow, look at all that investment they're making in security. But if we think of the engineers and we think of the people represented up there, number one is it's an outsized population problem. Right? The number of software engineers, you're never going to get one-to-one ratios of like AppSec or any other kind of security role. If you think of where most organizations seem to spend a lot of their time and resourcing, it's literally at the far right of the spectrum. It's the pen testers, it's the red teams. If you've been in a red team before, if you don't have a blue team at that company, your red team is going to be very successful. And we do this all the time in software security. We hire annual pen test. We hire people to break our code after it gets released, but make no investments at the start of the project. So when the third party comes in and they do a pen test, yeah, they're probably going to find SQL injection. If you've not educated your engineers, if you haven't supported them through the development lifecycle, getting that result isn't really kind of blessing the fact that you hired these pen testers. It's better than shipping the product, of course, with those vulnerabilities. But it's kind of actually indicative that you've not invested further left into the development lifecycle. This general picture, if you think of, what's the biggest population up here, it's the engineers. So why are we investing so much effort at the far end of the spectrum of the SDL? Why aren't we making those engineers, and if you saw Dino's keynote, these engineers are going to scale. We are never going to scale security programs to the size of an engineering staff. So why are we not investing more to make them security engineers and to supplement or to help them out along the way? Within Duo Security, when we hire new engineers, we actually have this pretty quick survey, and we want to know from the perspective of the people that we are to serve, because application security is a customer service role. If there are no engineers, there are no AppSec engineers. So we understand and want to understand better the population that we actually get hired to help. And if you look at HackerOne's data set from their recent report, 2 of the vulnerability classes that are the highest paid out bounties are server-side request forgery and insecure direct object reference. When we hire employees and we give them a bunch of bug classes, yeah, people know what cross-site scripting is, or they've heard of SQL injection. More often than not, they really sincerely don't know what IDOR or SSRF is. And how could you blame them based on the comp sci data we looked at? So if we see that the highest bounties are paying out for these things, and we see a huge disparity in the knowledge of our engineers, we now know where to invest time and where there are gaps in curriculum or trainings or boot camps. The other problem is with HackerOne's data, they show that there's only a 40% overlap within the OWASP top 10 versus the real world data they have. So because HackerOne's data is, again, taking a broad view of data from real world assessment, the OWASP top 10 is often driven by a small quorum of people that are, again, doing their level best to give a perspective, a snapshot in time of risk in applications. But HackerOne's data is actually what is happening in the real world. And if there's only a 40% overlap, there's clearly a lot we're missing. And then we have to address that. So the point Fletcher was making in passing, if you've been a software developer and you did web applications, let's say, before abstraction libraries or other things that kind of gave you a little bit of security glue in the middle, it used to be a little kind of Wild West, but now we have ORMs, we have capabilities, and that's great. But when you do speak to a lot of engineers, they say, oh, the ORM is going to handle the security. It's going to handle SQL injection prevention. If you go to Wikipedia, I think right now, unless someone's changing it actively, go to the SQL injection page, go to the mitigation section of that page. There's this one single line that says enforcement at coding level. And if you read that line verbatim and you don't know about this, you're not a person in this audience at Black Hat, you would probably take away that this is literally the right way to handle this entire problem. It's very terse, it's very to the point, and it's in the SQL injection page for mitigation, and it's one line. How simple. But the problem is, and luckily some of these great people have posted blog posts, the ORM doesn't actually protect against SQL injection in all places. Lots of other kinds of database libraries you think might be protecting you and they're not. And this gets back to the root cause of if the engineers don't know why these things work or do not work, how are we supposed to expect them to understand that in certain cases the ORM does something good, in some cases it doesn't? And we peanut butter over these kinds of concepts. Why aren't we talking to engineers like engineers? These concepts are not that hard. They're patterns and anti-patterns. They're interfaces. These are things that engineers do every day, but yet we keep trying to pull away the nuance that they would understand probably better than we would. If you've dealt with any sort of web application, you've probably had some password management. And again, when you talk to an engineer that's been in the industry for a while, based on the last, OWASP top 10 training they took, or the last, blog post they read, or the last OWASP top 10, overview, these are the kinds of things where a lot of engineers are like, oh, well, I don't use MD5 anymore, I use SHA-1. And, 20 years ago, great. Or I use SHA-1 plus ASALT, great. From 2011, this Flask authentication module, which was a very popular module, you see right there, it's using SHA-1 to do password storage. In 2019, there's a website that's a tutorial website for JavaScript, and it's saying to use MD5 client-side to protect people's passwords. And then when we see breaches happen, we go, well, how could this possibly be? Well, because tutorials are still telling people to do it this way. Despite all that, looking at as far back as 1999, we've had great password storage algorithms. But the time to education for engineers to know that those are the things you should be using, and then to ignore everything that's basically indexed on Google and Stack Overflow and curriculum that's out of date, that's kind of an uphill battle to know. You need to know that it's not okay to look for the answer that is okay. And that's such an intractable problem for most engineers. If they see a resource, it's voted up, as Fletcher said, why would they think otherwise? I wouldn't think otherwise if I was looking up a topic and a lot of people seemed really passionate about it. I'd be like, okay, that sounds great. So we have a re-education that really has to happen in many of these areas. But what is the source? How do we give that truth to an engineer? How do we make sure they're up to date real time? That's a tough problem. One of the areas that I think we are doing better as an industry, and you can see this in investment, you can see this in M&A, we're spending a lot more money and time and technologies into vulnerability management of third-party dependencies. So your open source libraries that everyone's using, that's great. And we're giving all that visibility to the engineers. That's also great. But what do we run into now? We're giving more awareness to engineers that don't understand the root causes of these vulnerabilities. So they're going to see a CVE, and they're going to see some CVSS 10 score, and they're going to be like, oh, wow, this is critical. I've got to patch right away. My source is in trouble. I'm going to get my website compromised. But what if the vulnerability doesn't affect anything they use? Like, libraries have a lot of functionality, and oftentimes a lot of CVEs are very tightly scoped. Oh, this one method in this one case with this one Boolean is affected by this thing. What if they have no chance of ever using that functionality? We're going to get into this habit of just patch, patch, patch. And if you've been a software developer, you know that just taking random updates for the trunk code base of any library, especially when you have like NPM with 800 imports, you are probably going to introduce more security regressions by doing that sort of strategy than you would have by not just patching the thing that wasn't applicable to you in the first place. So simply giving more visibility without the knowledge that's commensurate to actually handle that visibility is really just going to exacerbate the problem, going to create more friction, going to create more confusion, and possibly introduce more security issues. So from taking a lot of that, thrash that's kind of ahead of us or that we're walking into, it gets worse. And it gets worse because even when organizations do have an application security team, that doesn't necessarily mean that they're on the developer side. This was a quote from a conference I attended a couple years ago, and it was an application security person, and I was super excited to see the talk. And then it was all the dogmatic, condescending, points of view that we've been trying to get away from as an industry. And I think, again, Dino did a great job in his keynote talking about this. But when we have an application security engineer that really is just kind of going back and pointing the finger and blaming the engineer they're working with, but by the way, the application security engineer doesn't know how software works. They have no background in development. They have no comp sci degree. They are self-admitted, oh, I don't really do any of that. But they're the AppSec engineer. So are we really setting up anyone, including that AppSec engineer, for success at that point? It seems like we're actually introducing new problems that we didn't have without an AppSec team. So it's ideal to have an AppSec team at all, but if they're actually contributing to a negative outcome, or maybe they're going to introduce more false positives because they don't know what the tools are actually saying, are we really doing that much better, other than having a role that someone's LinkedIn title says AppSec engineer isn't that important? Within Duo, one of the things we did very early on was establish really the principles by which we were going to build our AppSec team. And this is something that I've seen other teams do, and I kind of learned from this in my career, where when you have all these choices in front of you and you have all these directions, you really have to have some anchoring elements of what is your team going to be? What is your team going to do? Who do you serve? What is the outcome that you're looking to achieve? So some of these that you can read off the screen, but some of these are obvious, but they're also not necessarily obvious in practice at a lot of organizations. And by pulling back to these at all times, we don't really ever get too far off one side or the other. We kind of recenter on these principles and these values for our team. So the idea that, and kind of the quote I called out a second ago, the idea that you're going to break people's code all day long. You are there to tell them everything that could go wrong, that is wrong, that's bad, that's kind of the ugly baby thing, right? We can do that, but we can do that in a respectful way. One of Duo's company principles or kind of core values is kinder than necessary. And wouldn't it go a lot farther with an engineer if you're like, wow, software is really hard to do right. And by the way, like these things are changing all the time. Let me introduce you to this library that's a little bit safer out of the box. So making the adversarial effort as a pen tester or an offensive person doesn't mean that the relationship that you are fostering is going to be adversarial. And in fact, if it's not, you're probably going to be a lot better off when you do want the thing changed. So when that bug goes out and there's a refactor cost and there's a lot of overhead and we're hitting that like 100 number that IBM showed us, that relationship is going to get the bug fixed when you want it fixed. Another one, and this is something that I think Netflix and a lot of other organizations have done a great job talking about, is this idea of building a paved road. It's very easy when you are in a security role to point out all the things that are going wrong, but what if you just kind of obviated a lot of that problem set and just told engineers what the right ways to do things are? Why not tell them, like, this library is really good, here's some guidelines on how to implement it correctly, we have security testing in our pipeline for that. Isn't that a lot better than like letting them whack-a-mole and then be like, oh, we imported this module. Well, you can't ship that. Cool, we imported this module. Nope. Why don't you just tell them what they can import? Why don't you just tell them what's safe and what's not safe? And instead of making this like circuitous kind of conversation, and this is again when you're focused on shipping product, when you're focused on the business, and you're not focused on finding bugs. Ideally, if you're a great AppSec team, you find very few bugs, and it's not for a lack of staff, it's not for a lack of trying, but you've invested so much in making sure that bugs don't get introduced. If you're finding a lot of bugs, it probably just means you didn't invest in the right places upstream in the development lifecycle. So I mentioned peanut butter earlier, and in some cases I think peanut buttering outcomes are probably good. This is a very high-res peanut butter photo, by the way. So we see the security development lifecycle from Microsoft up here, which we map all the work we do at Duo to. And then we look at the other side, which is this kind of sand, water, rock, whatever filter, charcoal filter. When people see the SDL, they just see it as a linear set of steps. And that's something that I'm generally opposed to, because I don't think that if you just do things in the order of operation, you're really getting the intention of the SDL. So this other image kind of shows what I think about, which is we are heavily investing at the very top of this funnel. We want all of the best things that we can give our engineers, tools and knowledge and awareness at that point, because that takes that huge pile of icon heads that I showed you a little bit ago, and that makes them security engineers. And now it's not an outsized problem anymore. It's a very tractable problem that we are ahead of, or at least in lockstep with. And at the very end of this, you see response. So that's your product security incident response. That's your advisories. That's the bug fixes in production. The 100 bar chart bar from IBM. We want to avoid that. And if you do everything you need to do, you get all the best code out of it, and your amount of response should be a drop in a bucket. So this is the kind of thing that it's not about just doing everything all the time across the entire SDL. It's really picking outsized and really force multipliers of where you're going to invest, and where better to invest in the people that you work with every day. Because the less they come to you for this random question or that random question, or the more that you build a security culture within their team, when they hire new people, that will cascade somewhat. There might be some attenuation in that signal, but overall, you're going to get a lot better results than not doing it like that. And for an industry that's really good at fetishizing the idea of rock stars, I would promote the idea of orchestras. You want composition. You want alignment with different people from different backgrounds and different awareness levels and different processes. And if you put people in the right positions, I think a lot of people these days hopefully have gotten to the point where you don't really hire necessarily for roles anymore. You hire for people, and then you align roles to them that you think they're going to be successful, that move along your program or your team. And if we did more of that, especially in application security, yeah, you might have 2 or 3 really good pen testers. But what about the person with a super deep knowledge of computer science that can do really crazy things in AFL fuzzing, right? Those are both important roles, and those are both important skill sets and job types. But simply just doing 100 static code people or 100 end of development lifecycle pen testers, you're not going to get the same value as if you intersperse your team with different skill sets and different roles. Simply doing all of that is good, but it's really about providing the opportunities for those things to occur. So if your engineering team has to run into you in the parking lot to get your attention, it's probably not going to be much more effective than it is today. So a couple of things that we do at Duo, and I'll dive into a couple of these for a little bit more time, but we have like a Slack channel of AppSec. If they come in, they ask a question, either we can triage them real time, we can say, hey, go through this process, or we'll follow up with you out of band. We also invite external guest speakers and just give them kind of knowledge transfer from different points of view beyond our team. And then we give them tool sets and other things that they can take advantage of directly. For engineers that have done an OWASP Top 10 training, you might have seen something like this, where it's the 1 = 1 SQL injection, it's the alert box for JavaScript. And this is all valid. I mean, there's nothing wrong with that. But I think if you've gone through a couple companies, you've probably seen the same examples every time. If you've done like, a vulnerable web application by design, you've probably done roughly the same vulnerability classes, seen the same exploitation. At Duo, in our Intro to AppSec class, we do things like talking about what happens if you have an encrypted session that you don't have a message authentication code for. Now, if anyone's had an Intro to AppSec class at your company that talks about something like that, I would be kind of shocked. A lot of people, I showed this slide deck to someone, and they said, oh, that's like some crypto class you have? I was like, nope, that's just part of the 101 AppSec course. Because we want to challenge engineers. We want to engage them. We want to talk up to them rather than down to them. We want them to meet a bar that maybe isn't set yet. That's the kind of thing that allows us to get people to come to us to take these trainings because they've heard good things about them and they're kind of bought in. A couple quotes up here from our team from surveys. And yes, when we do trainings internally, we do surveys. We want their feedback. We want to provide them a better experience and make sure that we're hitting the things that they need to know about. This is in addition to the surveys we do when they come aboard as a team member in the first place. So we've done a bunch of these courses. We've created many of them. And more than that, we've never required anyone to attend it. There is not a required AppSec training for any engineer. And this is one of those things, it's a distinction without a difference. When we say, there's this great training, we'd love to share it with you, it's very engaging, we're not gonna lecture at you the whole time, we get a couple of people to sign up and do a pilot. And then they start telling their other engineers and their manager, wow, that was a great training from the AppSec team, like you all should take it. So we get all these people attending with nothing but advocacy. We don't do it with threats, we don't do it with anything that would force their hand. They come to us because they want to come to us because we give good content. Isn't that a crazy idea? One of the other things we've done is we have office hours. So once a week in our Austin office and in our Ann Arbor office via WebEx for remote employees, we have office hours. You can come in, you can talk to us, you can ask us a question, you can have us look at code, whatever you want to do. And just one example up here where we had someone come in, they asked a very good, logical, important question, but we didn't know why they were asking it. And we pulled back kind of the layers and we decided that actually, oh, we weren't aware of that feature. Let's look at your design. And when we looked at the design, we realized that we had to refactor the design. So simply by giving the opportunity to come to us in the first place, I guess not got ahead of a problem, but we got ahead of the problem in the sense that they didn't ship the code, they could refactor for a much cheaper cost by just simply being available and being kind of welcoming. And everything we do is in their world. So when we find an issue, we file it in the issue tracker for them. We file it in terms, we give context, we give scope, we give solution ideas, but we never dictate. We always kind of go, hey, maybe over here, do this or that. And then when they start ideating on their solution, we help them out. So Fletcher's going to talk a little bit more about education modalities and how people actually learn and how maybe we can address that need a little bit better.
Cool. Thanks, Bert. Yeah, so to take a step back and just talk about learning in general, the ICAP framework is a really common way of thinking about learning, and you can kind of view it as a hierarchy from worst to best options in terms of engaging students in the learning process. Typically with security education, we're at that bottom tier, entirely passive. Watch this video, and maybe through osmosis, you'll take in some of the right lessons. Whereas as we keep engaging people more in the process, answering questions and ideally solving hands-on challenges, still guided with feedback, but contributing to the process, there's a lot more engagement, there's a lot more deep learning that's happening there. Many of you here know how to code to some extent, so how did you learn? You might have taken some classes, you might have watched a video, watched some tutorials. You probably didn't just sit down and read a book or have someone talk about coding to you. and then you could code. You had to do it. You had to practice it. And so if we want engineers to be writing secure code, we need them to practice it. It sounds simple when you put it that way, but it's really uncommon as a strategy. Have a developer practice writing secure code so that they can do it in their day job. I know education as well should be varied but ongoing, and it's hard to do that kind of training if it's an annual requirement, if it's something that only lasts for a few hours and then you can kind of forget about security for the rest of the year. Instead, we end up with a lot of training experiences like this, generic multimedia, sit down and watch it, and skills assessments like this, where we say multiple choice tests, maybe you can, by rote memorization, take in some terms, but it's not actually practicing secure code, so it's hard to help you in your day job there. Or at best, we teach engineers how to hack, because that's the fun part of secure code. Allowing them to pop a shell is kind of fun to watch, but teaching them to patch is a separate skill. So here, the common case of let's do an in-person workshop, and you'll play around with damn vulnerable web app and run SQL map. And great job, you did it. Now don't write code like that. We kind of skip the most important step there a lot of the time. And the lesson that gets taken away is, of course I'd never write code like that. That doesn't look like code I would write. And this one particular example, I know how to hack it with the 1 = 1, and so we're going to move on. Instead of actually practicing, how do we patch this up? What do we do from here? What are the trade-offs? Why would someone have written code that looks like this in the first place? Maybe they had some good reasons. Instead, as busy, outnumbered security professionals, we end up saying, you can't be trusted to write secure code. Now, that's a good mental framework to take as a security professional. You shouldn't trust anyone to do anything. But you can't start out the conversation that way. It's a great quote from the OWASP chairman here. It's the wrong approach. It's like going up to a parent, saying their child's ugly and expecting a conversation. Starting with, you can't do that. Not a great way to start that conversation. So instead, as Mark mentioned, we need to engage with engineers as peers on their level and speak to them as the smart, intelligent, capable developers that they are. We have seen some progress in terms of tools like NPM Audit here, companies like SNCC or recently GitHub Alerts. All of these are integrating more closely into the engineer's day-to-day. Again, these are just for third-party vulnerabilities, not necessarily the own code that you write, but starting to give folks more feedback within their workflow. This is a quick screenshot, and we'll show a little demo later of an actual Duo lab in Hunter 2. The most important part, as we keep hammering on, is to give developers a chance to actually practice writing secure code and to give them guidance and feedback along the way. So this is part of what we'll be releasing to the community, where you can see on the right side here, a developer is actually tasked with patching up the code of a vulnerable application. And they're given automated feedback through that process on whether their fix is working or not. But because it's a real app, they can actually play around with that and see what's possible. So we're going to talk a little bit more about growing the community. I'll hand it over to Mark.
So like all good conference talks, that sounds great for your company. What are we going to do about all this? So one of the things we're going to be doing to really help kind of seed the ability to maybe create a program that's a little bit different, or if you don't have an AppSec team in the first place, but you have a security function and you're looking for resources that are maybe more available. Duo Security internally, I mentioned we do trainings. We've built those trainings from scratch, ground up, on the curriculum and content that we think is important to developers. The first time we built a class, it was our Intro to AppSec course, and I sat down with my team, which was very small at the time, and basically the only ground rule was we will never mention or talk about the OWASP top 10 today. So we did an outsized exercise of look at all the resources, look at vulns we've had internally, look at libraries we use. Let's come up with a list of things that we care about and that we think engineers will want to know about that are part of Duo. And what we ended up with is a training that we've been giving for, I think, about 18 months now, really good results. We refine it as we go. We also have an advanced AppSec course. So just kind of taking the next level for a lot of our engineers so that if they like the content from the first class and they, again, advocate for it, now they have another opportunity. So we're going to be releasing our internally built intro and advanced AppSec courses as part of Cybersecurity Awareness Month in October. That courseware has a lot of labs, so over 20 labs across the 2 courses within that 102 platform. So when we give a little bit of lecture, we give some context, we give some education, then the engineers sit down and do a lesson, they exploit the code, and they patch the code. So we're trying to give real-time kind of awareness and feedback. We're trying to engage developers the way they work, and we're trying to create like a relationship between the lecture that we present and the lessons that we're providing them. These are things that within your organization will provide speaker notes, we'll give some lab guides where relevant, and certainly this won't solve all problems for all companies, and the languages we use or the kinds of lessons won't be applicable. But we also want to open this to the community to provide a little bit more of a chance. There are other great companies like PagerDuty that have released content on like their AppSec course, for instance. So we think just there's not enough content, there's not enough visibility into what actual real programs are doing in the world, and we just want to help seed the pot a little bit more to provide a better outcome. As part of the 102 platform, we've created 7 custom lessons. So this isn't kind of in the core platform. These are things that we've built because we found it relevant to our engineer that they would benefit from, or kinds of bug classes that we didn't see coverage for. So we're also going to be open sourcing these. We're going to be putting these on GitHub. We hope other participants in the community will also build some lessons, release them open source, and just kind of keep that curriculum up to date. Because again, when we look at things like the OWASP Top 10 and we see vulnerability classes that are either A, not represented, or B, not going to be talked about for 3 years, when that crazy new SAML vulnerability comes out, wouldn't you like a challenge the next week to actually tell your engineers about the real-time risk that's facing them as engineers? And the only way we're going to get to that idea of time to education and reduce it down to a kind of important timeline is by having a capability to do this on our timeline, our schedule. The things that matter to your engineers don't have to be 2 years down the road, they can be tomorrow.
So before we wrap up, we just wanted to show a quick example of this in action. Not a live demo, I have not prayed to the appropriate gods. But this is an example of one of Duo's labs where they've cloned essentially a small Python Flask application, intentionally vulnerable, into the Hunter 2 platform to give you sort of a sandbox to play around with it. This is a simple make transfer type of application where you interact over an API. So hopefully this video, there we go. This is about replay attacks. Again, not something that you would typically cover in an intro type of class. But we're going to start by exploiting this simple application. You can see step-by-step instructions on the left, a real terminal where you're interacting with a server on the right side. And the user is just starting out with sort of a toy example. There's no authentication, so they can just keep transferring money for any user along the way. But this is a fully functional API. So they build out registering a user. This will pop up with the browsable API of this set of this application that's been spun up just for them. Log in that user and play around with what's possible on the different endpoints of this application. From there, they get to hack it. So you're actually performing a replay attack. Now, again, we're not teaching you to be an expert pen tester. So we've given some starter scripts in terms of automating some of this through a little bit of Python. But it's still up to the user to go through what this means, how it works, and actually go through the process of, in this case, replaying their own user's session to get more sensitive info about other users in the database. And this is giving them feedback throughout the process. So if they want to try this a different way, they can do so. Finally, we patch it up. So we're actually practicing here writing secure code. We'll give some snippets, some suggestions of how to do this. In this case, we're adding a little bit of randomness to the hash of what gets sent for a request. And then we test it out and see that in fact, prevented the hack that we were trying before. Now, of course, that's not a perfect solution. And so there's also room at the end for additional trade-offs. It's all about defense in depth. It's all about what is the right patch or the right set of security controls for this particular situation. And because it's a real app, you can continue to play around with that. an exercise for the reader of you can try out other patches, try out other ways to exploit. So we encourage you to join us. As Mark mentioned, we'll be releasing some of these labs as well as the other training materials. And we encourage you to contribute your own examples as well. We have a link down here that will have our slide deck to download, as well as you can be informed of when we release this. And I'll hand it off to Mark to wrap up.
Great. Well, thanks for finishing up your Black Hat with us. We appreciate you staying, not going to get dinner, not getting ready for the party. So with the kind of curriculum we talked about today, we again hope to kind of get the process started for your organizations. It's a tough challenge to do this from scratch, so we're going to seed the pot a little bit to get you farther ahead. But we look forward to having you sign up. Let us know what you think of the talk via your feedback forms, and we're going to go head over to the wrap-up room. So if you want to talk a little bit more about this topic, what your organizations are doing, or kind of other perspectives we have on this topic, we'd love to chat a little bit more. So again, I'm Mark, this is Fletcher, and thank you for your time today.